How does an infant begin to understand the world around her? How does she learn to interact with it? And can we build robots that learn in similar ways? Discovering their environment by following a drive to explore. A form of curiosity that allows them to define their own learning goals and practice behaviors they find interesting. In the Goal Robots project, we study the behavior of human infants and we develop robots that can learn in similar goal-directed ways. Goal Robots is a European research project led by 4 partner institutions in Italy, France and Germany. The Italian National Research Council in Rome, the University Paris Descartes, the Technical University of Darmstadt and the Frankfurt Institute for Advanced Studies. We work with a number of research platforms ranging from very abstract and simplified simulations all the way to complex humanoid robots. What these systems aim to demonstrate is how robots can autonomously learn a rich repertoire of skills by defining their own learning goals and later apply these skills to solve a large range of new tasks. Learning a new skill can take a long time. One way to speed up learning is to start by trying an already known solution to a similar task. What defines a task and how much the learning can benefit from past experiences are central questions. In this example by the Darmstadt team, the current task is to push an object along a line. Learning this behavior is far from trivial, but already having learned to solve a similar problem can greatly speed up the process. Next to learning such fundamental motor skills, it's equally important to learn how to perceive the environment. Much of our behavior is guided by vision. Therefore, in a collaboration between the Hong Kong University of Science and Technology and the Frankfurt team, we also investigate how robots can autonomously learn to see and understand the world around them. We have developed new learning algorithms that allow a robot to visually explore the world around it and make sense of the images falling into its 2 cameras, giving it an understanding of the 3-dimensional structure of the world. The same learning approach also gives rise to the ability to track moving objects, providing a basic repertoire of skills for visual interaction. Perceptual skills as well as motor skills need to adapt to changes in the agent's body, the environment, or the tasks to be performed. Specifically, autonomous robots need to interact with unknown, unstructured and changing environments, constantly facing novel challenges. Continuous online adaptation is crucial in these situations. The Darmstadt team has developed a novel framework for motion planning to address this problem. By using an intrinsic motivation signaling cognitive dissonance and a mental replay strategy, the robot can adapt to novel environments in seconds. Here, the robot quickly adapts to an obstacle that is blocking its path along the 4 yellow goal positions. After just a single experience, the robot successfully avoids the obstacle during future executions. Learning a repertoire of such basic skills that can adapt to new circumstances prepares the robot for learning more complex skills. For instance, learning to touch or grasp a target object can be made much easier by first learning a set of simpler component skills. In this example, developed in collaboration between the University Clermont-Auvergne and the Frankfurt team, a robot first learns to fixate objects with its 2 cameras. In the second phase, the robot learns the skill of eye-hand coordination, acquiring knowledge about the geometric relationships between his cameras in his hand. In a final learning phase, the robot utilizes these learned skills to learn a third, more complex skill, touching the goal object with its palm. After a robot has autonomously acquired a large repertoire of such skills, we want it to be able to use them to solve user-defined tasks. In this example, developed by the Rome team, the robot is guided by an attentional system and visually explores a table with 3 colored cubes. The robot is able, through simple visual and motor reflexes, to move the objects on the table with its right hand. The task is to put the objects in a desired goal configuration, which is specified by a human instructor. This task approaches the final aim of the Goal Robots project. Robots that can autonomously learn a large repertoire of skills by defining their own learning goals and using the learned skills to complete novel tasks provided by human users.